Alrighty, let me tell you about week 14. And week 14 is pretty much entirely extra credit. But if you do enough of these extra credits, you don't have to deal with the final project pretty much, but it's up to you. Okay. So, week 14 is the main thing is I want to tell you about dictionaries. I also want to tell you about hashing and encryption. So it's just like a lot of interesting things that you can do with Python. Probably a little bit beyond the scope of this class, but they're not too hard. So I'll show them to you. So first of all, dictionaries are something that is kind of unique for Python. It's another one of those you want to call it data structures, or ways to organize a bunch of data, similar to lists in a way that you basically have a list of things, but instead of indexes, instead of identifying each of these elements by their index as a number, you could use letters, right? So remember, if you had some kind of a list, let me open up idle so I can show you. Alright, so remember the regular list, a list is equal to square brackets, right? That's an empty list, and if you have A, B, C in that list, then you identify A as a list 0. Alright, that's your A. Okay, well, a dictionary is different. What you have is you have in here, if we actually had this, right? That is how you make an empty list with lists. And by doing this is how you make an empty dictionary. Okay, so the dictionary is different, that it has curly brackets. The list has square brackets. Okay, so other than having a list created this way, right, what we can do is we can create an empty list. A list equals square brackets, right? And we can append a list, append A, right? A list append B, a list append C, right? And that will create this list up here, basically, right? We start with an empty list, we add 3 letters to it, and then if I wanted to show the first one, right? Like before, this is your 0, this is your 1, this is your 2, if I wanted to. Okay, so with a dictionary, what you're going to do is, if you want to make an empty dictionary, you say basically this right here. I'm just going to copy it. You do this, right? That's an empty dictionary. And then if I wanted to add things to the dictionary, instead of using append, I just do this. All right? So this will be the first thing that I add to my dictionary. Okay, if I wanted to add another thing, then I can do this. Right? So now if I wanted to show, so before with a list, if I wanted to show this, I use a number, right? And with a dictionary, basically, if I wanted to show this, I would use this particular key. Okay? So it really literally works as a dictionary. And it uses something called hashing, right? And I'll talk about that in a second. So basically this dictionary here at the bottom, if I wanted to print the whole dictionary like so, right, then I'm going to get this result. And I'm not going to run this thing just so you can see it, right? So this is the first thing that is on the list, and it's identifiable by this, and this is the second thing that's in the list, and it's identifiable by this. And when I say first and second thing on dictionary, the order in which these things are going to be placed in a dictionary is not always going to be the same. So in other words, if I do A, B, C in a list, it will always be arranged in this particular way. But if I add a whole bunch of different words into a dictionary, then they're not always going to be arranged in the same way that you see originally. So that's just the way, that's kind of like a property of how hashing and dictionaries work. Okay, so I just want you to understand that this is what dictionaries are, and this is how we use them, right? So if I wanted to show you this particular thing here, then I would do this. All right, I would just do print this, right? Will show me this string right here. Okay, so that's what it's going to show. Any questions? Pretty basic, I hope. Right? So it allows us to quickly access different things that are in a list, and allows us to basically place, either search from a list of things quickly, or place something into a list of things quickly. And what it uses is, let me show you a little bit something about hashing. Oh, and by the way, I have a dictionary PY, a program in here that is going to, let's have a look at that. It's just another example of a dictionary. So this time I'm not adding to the dictionary. I'm not making an empty dictionary and then adding to it. I am starting with a dictionary that has already things in it. And how do you place things initially in a dictionary? Well, this way, right? So this is going to be the identifier of whatever is stored in there, and this is the value that I'm going to bring up. Right, so if I wanted to look at the temperature, right, this is a dictionary of the different temperatures for different cities, right? So if I wanted to look at Santa Cruz, right, it's going to show me this value. If I wanted to look at San Jose, then it's going to show me this value, right? The value could be a string, could be a number, right? Could be a list if you wanted to, okay? So yeah, these are your keys, these are your values, and pretty much that is how dictionaries work. And one thing that we're going to use these for is this assignment right here, which is your Caesar cipher. Okay, and the Caesar cipher, I don't know who came up with it. I'm pretty sure it wasn't Caesar, but right, he probably took credit. And the way it works is you're going to have some kind of a message with the regular words of that message shifted. Each letter is being shifted forward by a certain number, right? So for example, every time you're supposed to have a B, you're going to shift this thing down, or let's say, yeah, we're going to shift it down 3 letters or 2 letters. So this is first, second, third, and then every time you see a B, it's going to be translated to an E. So if you know by how much the letters are shifted, you can get a encrypted message and then do a backward shift, and then you can decrypt it. Right, that's the encryption and decryption. So, an example here is basically each letter is being shifted forward by 3 letters. Right, so the A turns into a D, the B turns into an E. Right, so you have basically your regular alphabet and your encrypted alphabet. Okay, and what I have in here is an example of implementing this Caesar cipher. Okay, so what I do is I create a string. Let me zoom in on this a little bit. All right, so I have created a string called alphabet, and then I'm going to go through my ASCII numbers from 65 through 91, which are, I don't know, it's either the uppercase or lowercase letters, right? So I'm adding all the lowercase letters or all the uppercase letters to this string called alphabet. And then I can show it to you. Then I'm saying, okay, there's going to be a shift. This is going to be my shift 3, right? And then I'm going to create an encrypted alphabet where it's basically the same thing as my original alphabet, but I'm adding a plus shift. Okay? And because what's going to happen is, remember, the letters are from 65 to 91, my shift is going to force. When you get to the end of like letter Z, right, when you do another shift plus 3, it's going to push you and show maybe some weird character. In order to do that, right, what I do is I have to do this if I plus shift is bigger than 91, or we went beyond the Z letter, then we're going to do a little subtraction. We're going to subtract 91 from that number that we get, and what's going to happen is we're basically telling it, okay, if you go all the way to the Z, then wrap around and go back to the A. So if you go 1 over, it shows you the A. If you go 2 over the Z, it will show you the B. If you go over 3 over the Z, it will show you the C. So that's the purpose of this shift that I have in here, right? So that's the wraparound. And then I'm going to show you this encrypted alphabet, right? So if I do that, then it should show you the alphabet on top and the encrypted alphabet on the bottom. Yeah? And then the next thing is, what I'm going to do is I'm going to make a dictionary, right? So first I make an empty dictionary called encrypt, an empty dictionary called decipher, right? They're empty because there's nothing in the curly brackets. The next thing is I am going to add, in here you see encrypt, square brackets, quote, space, quote, square brackets, and then equals, quote, space, quote. Okay, and these are single quotes. So there is a space in there, and the reason I'm doing that is I'm basically telling it, every time you see a space, leave it as a space, right? We don't have to do that, but it will just make it easier for you to see what you know, what is a separate word, right? In other words, if I give you an encrypted word, if I give you some kind of an encrypted message, I'm telling it leave the spaces as is, right? So at least I'm kind of showing you, you know, more than I should, right? Because I'm showing you that there's spaces and there's a 1, 2, 3 words, but I'm doing it on purpose, and that's the reason why I have this. That's the reason why I'm adding this blank quote into the encrypt and the decipher dictionaries. Then I go in there and I make a loop that goes through the entire length of my alphabet string, and then for my encrypt dictionary, I'm telling it every letter of the alphabet, put that in a dictionary as the key, and make it equal to the encrypted version of that letter, right? And then for the decipher dictionary, I'm adding every encrypted letter of the alphabet as a key and making it equal to a value of the actual alphabet. Okay? So what is that going to do? Well, we're going to have some kind of an original message. This is your original message. And then you're going to make an encrypted message, which is blank. And then the original message is, if there's a space, you're going to leave it as a space. And otherwise, you create an encrypted message using encrypt message, your encrypt dictionary, using the original message, which is that string right here, as a key for your dictionary, right? So we're going to plug in every letter of the original message into my encrypt dictionary, which is going to generate the encrypted message letter by letter, add it to my encrypted message string, and then I can show you both of them in here, right? So what you're going to do is, your assignment is basically type up this program. That's why I have it as a picture, and see what it shows you, right? So it's going to show you hello world, and then underneath it, it's going to show you the encrypted version of the hello world, whatever that is. Okay? So what you have to do is, and then there's a loop underneath there, so you can run this loop and see how it's going to show you the deciphered. Let me zoom out of this a little bit. All right. So this one right here is going to show you the decipher message one by one, right? Letter by letter, I mean. Anyway, if you type up this program and get it to work, you're going to see how it's going to encrypt something. And then what you have to do is, I give you an encrypted sentence. So this is the sentence. And I'm telling you that now I'm changing the shift to 13, so it's no longer 3. So you have to change a couple of things in the original program and tell me what is the deciphered message, right? So what is this actually really saying? You can't see it, huh? What's going on with this projector? Sheesh. Yeah, that's beyond my control. Sorry, folks. Does that make sense? Let me know if it goes out again. Was it going out a lot, or did it go out when I just looked at it? Huh? A couple of times? Okay. All right. Yeah, that's this piece of the puzzle. The other thing that I have for today is protein weight. All right. And it's another practical application of dictionaries, right? So if you don't know, right, these are the different amino acids, and those are the letters for the amino acids. Using these amino acids, you can build protein strings, right? And you can determine the weight of some kind of a protein string based on the sum of its amino acid values, right? So what does that mean? That means that somebody can go in there and type in a protein string, something like this, and using the values that you have in here, right, you're going to calculate a total value of these, right? So you're going to add the value of S, the value of K, the value of A, D, Y, E, K, right? So what you need to do is you need to put this and put it in a dictionary, okay? And as far as the file is concerned, I can put the file in there for you, or you can make your own file. But let me edit this thing. Save you some typing, yeah. I don't know where it went. Files. There's a text. Save. And does it show? Yep. It should have been there originally. I don't know why it went. Okay, there you go. So there's your text file. So you're going to read that file, put it in a dictionary, and then calculate a protein weight based on its amino acid content, whatever. Okay. So there you go. Now you have a practical biology example in case you want it. We got practical decryption problem. And now I am going to tell you a little bit more in detail about hashing, which is used in this fun little assignment that I came up with here, which is brute force password crack. Okay, so first of all, brute force password crack is I came up with some kind of a real world problem. I don't know what background story you want to come up with, but you got somebody's information, okay? Maybe you're social justice warrior and you're trying to fight the evil corporation or whatever it is. Whatever makes you feel good, right? You're on the good side, or if you want to be the bad hacker, go for it. But your mission is you got to hack this password, right? So the idea is you went in there and somehow you got pieces of information, right? So these are the different pieces of information, right? You have somebody's name, you have somebody's date of birth, their social security number, right? Their phone number, and their pet name, all right? So what you're going to do is, and I tell you, the password for this thing here is a possible combination of 3 of these things. And by 3 of these things, it could be like the first name of the person, and maybe their year combined with the first 3 digits of the phone number. All right. So there's separate pieces to this, right? There's first name, second, third name, the pieces of the birthday, the pieces of the social security, right? We're assuming these are going to be the different pieces, right? Of course, it will probably not be that nice. All right. So all these different things, we're going to put them into one big list, right? We're going to split all these different things into pieces, and we're going to make one big list of these possible things that we can use as a password. And then we're going to have many possible ways to arrange them, right? So it could be something like this, could be something like this, right? And there's actually 2,184 possible ways that you can arrange just these pieces of information, right? Okay. So now that you know that it's going to be one of these 2,184, you have to tell me which one is the correct one. And in order for you to determine which one's the correct one, you have to hash, right? So what does that mean? So let me see if I have a link in there. File format hash, take me. Okay, so let's say, for example, I have a string here, and I say hello world, right? If I hit the hash button, and it's probably somewhere on the bottom, you're going to see a bunch of different ways that this information or this message is encrypted, if you want to call it that, right? It is encryption, okay? So this is my original text, and these are the possible different ways to encrypt this thing. Okay, so actually some of these, like for example the MD5 hashing, were used as a real encryption. And what's the practical use of this? Well, every time you log into your computer and enter your username, right? It is associated with some kind of a password. but that password is saved in your computer, not its original form, right? Not hello world 101 with an exclamation or whatever, but it is saved in its encrypted form, which means it's saved as something like this. Okay, so if my password on my computer was hello world, and I am saving that and I'm using MD5 encryption to save that password on my computer, then it will be this piece of text right here. Okay, so if I went in there and I just changed something slightly, so this is what it used to be, right? But if I go in there and I just change one little thing, let's say I'm going to make hello world uppercase here, hash again, you're going to see that now it's a very different number, right? So just by changing one little thing, the number that is being generated by the hashing algorithm is completely different, and that's what you want. So the good thing about hashing, or the reason why we're using hashing, is there's no way for you to reverse engineer. I mean, in other words, write a program that's going to look at this number and say, okay, magically it came from this combination of letters and words. It's just because of how hashing works. It's not possible. Okay? So what we're going to have to do is, in order to guess the password, we're going to have to try to guess a whole bunch of different words. Right? Is it hello world with a lowercase letter? Is it hello world with an uppercase letter? Just keep guessing and guessing and guessing. And if at any point my guess happens to generate that same exact hash that I used to have, and it will, right? For the same letter, for the same combination of letters and words, it will always generate the same hash. All I have to do is I have to say, oh wait, I just generated something that matches what I have, which means that the combination of words and letters that I used is the actual password. Okay, so that is brute force cracking a password. And there's software for this, right? There's actually programs that will do this for you in a way. One is, I think it's Jack the Ripper or John the Ripper. I can't remember which one it is. It's one of them. It's basically a program that does this kind of work for you. But what we're going to do with our program is we're going to do the whole thing that the program does, not just pieces of it. So in other words, there's software out there that uses rainbow tables. And what's a rainbow table? All right, Project Rainbow Crack. So if you go in there, you can actually download tables, gigabytes worth of tables of possible passwords. And this is, a lot of this is just for English language, right? If you want to try to hack Chinese passwords, there's going to be rainbow tables for that too, maybe. Okay? And notice this. There's MD5. Some of these are MD5 hash rainbow tables. Okay? So if you know that you're working with like some old computer system and that thing uses an MD5 hash, then you can use this table. And you basically tell the software, look at all these tables and try to find a hash value that matches, and then if it matches, then in the table it also has the stored guess word or whatever, possible password. So what we're going to do in our program is we're actually going to generate the rainbow table ourselves too. Okay? So, all right. So how are we going to do this? Well, first of all, we're going to have to, I already told you, we're going to have to get these pieces of information, break it into pieces, and put them in a big list. Then get all the pieces from in the list, and then rearrange them in groups of 3 without any repeaters, right? So if we have already arranged this thing this way, we're not going to rearrange them in the same exact possible way twice, right? Only once. So now that this is done, we're going to have a list of 2,184 things, and we're going to hash each of these using Python's MD5 hash. All right, so where's this thing that I show you? Right here. So there's a hash lib library in Python, which allows you to literally do this hashing that I just showed you in this way. So you're going to have some kind of a string. This is the string. I'm telling it we're going to encode this string using the UTF-8, right? Then we're going to do an MD5 hashing on this, and then we have to do a hex digest, and then finally this is the actual hashed string that I created, right? So if I wanted to hash this into this, then the string is this, and this final piece of text right here is the digest. Okay, so you're gonna have to do this for every possible one of these different possible passwords. All right, so we're gonna have to hash each of these and check to see if any of these hashed passwords matches this one. Okay, so if there is a match, right? Let's say, for example, you matched this here is equal to this. Well, then this is your password, right? And I'm pretty sure that's not the password. Okay. All right. So how are we going to do this, by the way? So first of all, we said we're gonna grab this whole thing and put it into a list. Okay. So suppose this is the list, right? We have a list called 1, 2, 3. We're gonna say split this list. Right, that makes a list of separate elements. These are 3 separate elements on a list. If I wanted to arrange them, right, so it's going to make a list of 3 things like this, right? And if I tell it itertools, permutation, split name, R3, right? What is the split name? Split name is basically the list, right? So I'm telling it, get this list and rearrange it in every possible way in groups of 3. So then it's going to create a list of lists, basically. So this here becomes a list of this list, and then another list, and then another list, which is all the possible arrangements that I can arrange these 3 words here. Okay? Then what I have to do is, so now this list, and this is how we're going to generate our this here, this is going to be the list which we create by splitting all these different things and putting them in that list. Okay? Then we're going to tell it this exact thing right here, and that will rearrange everything in groups of 3 without any repeaters. Then we have to grab each of these groups of 3 and we have to join them like this, right? So if I have this kind of a list here, and I say that's the list, right? So list 0 is this one, right? So remember, since here we have a list of lists, right? Info list 0 is this one, right? So let's say that's what we're getting. And if we're joining this thing, what it's going to do is it's going to turn this piece here into this, okay? And then what we have to do is, then we have to encrypt every one of these using this hash lib that I told you. Basically, you're going to, once you join it, once you get this piece of information here, you can just say word is equal to that thing, or whatever you joined up here, and then use everything underneath it, and then your digest is going to be the actual hashed password. Okay? Too much? Don't worry about it. I actually even have a more easier version with more hints where I pretty much walk you through the whole thing. So if you get stuck on the other one that I showed you, look at this, right? And if you still get stuck, let me know. Yeah, it's totally doable. Any questions? I hope you give it a shot. And if you don't, huh? Yeah, it's an interesting little thing. I figured just why not. And I know it's a little bit complicated, but that's why I went in there. So in the original version that I just showed you, that's the one with the fewer hints. And then I did another one with more hints than that. So if you get stuck on the first one, look at this. And if you get stuck on that one, send me an email and I'll help you out. Okay? So that is pretty much what I wanted to tell you about week 14. Week 14 is hashing and dictionaries, and now you know about it. And if you want to know even more about it, take the data structures class here that I teach, either C++ or Java. Okay, and then in there I'll talk about hashing in more details, and you'll see it. Okay, we're good? Any questions? All right, so I'll post the video for you, and